So let us look at the what? The vector form of Coulomb's law. So you can see that what the first aspect with this is ordinary Coulomb's law. So in this class now, our interest is the vectors form of Coulomb's what? Coulomb's law. Let's consider, see what? Consider two charge Q1 and Q2 whose position are R1 and R2 respectively in the graph below. So we want to look at what? The vectors form of Coulomb's what? Coulomb's law. Yes? Have a vertical axis graph look at the graph. If here we have charge Q1 and here we have charge Q2. Note at what? This point here, assume we have Q what? Q1 and here we have Q2. The distance, this place is what? Is origin. Here is R what? R1 and here I call it what distance what? R2. So if I joined what? R Q1 and Q2 together like this. This point here, we call it what? R. This is the vector R1, R2. Are we? So you can now say what? So from this sketch, this is charge Q1, Q2. Distance of charge Q1 from origin is R1. Distance for charge Q2 from origin is what? Is R2. So from the graph above, from what? The graph above, displacement, this what? Displacement R can be determined by R can be determined by, you said R equal to the what? Vector R2 minus R what? R1. This is the formula used to determine what? Displacement what? R. This is what? This R represent displacement. To know the displacement, what? R, it should be what? The R2 minus what? R what? R1. And we can also ask that what is the magnitude of what? Magnitude of displacement R. To know the what? The magnitude. Let me use another marker. To know the magnitude or let me write it here. Magnitude what? Magnitude of displacement what? R. The magnitude of displacement R will be what? R magnitude will be R2 minus R1 magnitude what? Magnitude. This formula is used to determine displacement R. This one is what? The magnitude of what? Display what? Displacement R. And the next thing is what? We can also ask to find the what? The unit of displacement. Meant what? R. Like what we applied here for this R displacement, we can find its magnitude and its what? Unit. The unit of displacement is then as what? A unit vector. From the knowledge of what? Of vector. The unit of displacement R is will be what? It will be displacement over magnitude of what? Of displacement. Displacement over what? Magnitude of what? Of displacement. Or we can also write it in this form. The magnitude of this. What is displacement here? Displacement here is what? R plus R over what? The magnitude of what? R2 minus R what? R1. This is what we call what? The unit of what? Displacement. Don't forget that what? We are still on the what? Vector form of Coulomb's law. If you could still remember, in the Coulomb's law, we are dealing with charge and distance that separate the two charge. So this is the two charge, Q1, Q2. The distance is what? Is R. So before we go to the real vector form of what? Coulomb's law, let me formulate a question here to solve. Here, example 1. So yeah, let's solve this example 1. The position of displacement of two are D. What is the first point? We are given the position of these. That will be what? What? Solution. Say what? Solution. Given what is position R1? Is this I plus 2j plus k in meter. R2 what? 2i plus 3j minus k in meter. Are we? The next thing is what? Respectively. Yes. The question number 1, you are asked what? To find displacement. I told you that what? The displacement between the 2 points is what we call what? R. And the formula for displacement is R vector will be equal to what? Vector displacement 2 minus vector of what? Second displacement. You will have displacement to be what? Yes. We have what is 2I plus 3j minus k. This is 2. Minus everything we have here, 1I plus 2j plus k. What do we have? R 2I plus 3j minus k. Open this bracket. Minus times I minus I. What do we have here? Minus times 2 plus 2j minus times k minus k. By adding it together, we have what? How many 2a? I here, 2I minus 1I. Here we have 1I. How many j? 2j plus 3j here plus 5j. How many k? Minus 2k. That is what? Displacement. And the next question here is what? We are asked to find what? We are asked to find the magnitude. What? Magnitude of the what? Of the displacement. Like I said, the magnitude of displacement it should be equal to the what? Displacement magnitude of what? R2 minus what? R1 magnitude. So the magnitude of displacement R, it should be what? What is the displacement? This we have what? I plus 5j minus 2 what? 2k. If you are looking for the what? For the magnitude, you will square. What is the coordinate of I here? Is 1. Write 1. Coordinate of what? Of j here is 5. Coordinate of k here is 2. Next thing you do now is what? Square this, square this, square this. Find their what? Square root. That's how we find the what? The magnitude. Coordinate of I is 1. Of j is 5. Of 2 is minus 2. Then square. By squaring them, you have by squaring them, we have what? I square of y, 1 is 1. Square of 5 is 25. Then square of this is what? Is 4. Altogether, we have what? 30. So the magnitude of displacement is what? With what? With 30. Then what will be the what? The unit what? Unit vector. It's like there is a mistake here. R1 is plus here. And I put what? Minus. So I put minus. So this, yes, here will be plus. Later they will cancel what? Each other here. And then there is no more what k. Give. Yeah. What is it? We have what? I. We have 1, 5, square, square. So the magnitude of this, we have 1 plus 25. It will give you what? Square root of what? 26. Yeah, the last question is we are asked to find what? To find the unit what? Displacement. Roman figure 3. Unit displacement. It will be what? Apply the formula for unit displacement. What is this? Say what? R unit will be displacement over magnitude of what? Displacement. What is the displacement R? We have I plus 5j. Magnitude is what? Root what? Root 26. This is what? The magnitude of what? Of displacement. So this, what I want to deduct here is, I want you to understand how we can determine displacement, magnitude of displacement, and what? Unit of what? Of displacement, before I will now try to what? To write out the vectors form of Coulomb's what? Coulomb's law. Because this displacement is one of the what? The component of what? Vectors form of what? Of Coulomb's law. So with this now, the vector form of vector form of Coulomb's law can be obtained as follows. In vacuum, which is free space, the force is kq1 q2 over what? R square. So where this what? R, where R is equal to the what? The magnitude of what? Displacement. This R here, because of the what? Magnitude of what? Displacement. We can now have what? The F to be what? K, Q1, Q2, everything over what? Magnitude of displacement square. This is what? The magnitude of what? Of electric charge in Coulomb's what? In Coulomb's law. But force, you cannot, this is the magnitude of force. In the second one is what? You can also have what? Vector form of force and its direction with the same with what? Direction of displacement. So for this case, we have what? Force F to be what? K, Q1, Q2, for what? Magnitude of displacement square multiplied by what? Or multiplied by unit of displacement. Unit of what? Displacement. What is the unit displacement? Is this? You cannot say that what? Where what? Unit displacement is what? Displacement over what? R2 minus, let me say what? Is R2 minus R1 over R2, R1 magnitude. So you will now substitute for the what? Unit of displacement A. We have F to be what? Q1, A, K, Q1, Q2 over what? Magnitude of displacement minus this square multiplied by what? The unit here is what? R2 minus R1 what? R2 minus R what? R1. So by multiply it with what? With each other, we will end up with what? The force will be Q1, Q2 over what? This multiplied by this will end up to the what? Displacement R1, R2. It will give us what? Raised to power what? Power 3. Everything into what? R what? R2 minus what? R1. So this is the formula for what? The force and the direction, or you can use this formula where this is what? Displacement. So let us look at what? How we can use the vectors, the co-vector form of Coulomb's law to solve problem. So let's solve these two questions by applying the vectors form of Coulomb's law. The solution to question number 1, we are given the R1, no solution, charge Q1 is what? Plus 2 microcoulomb, taken as what? Plus 2 times 10 raised to power minus 6 coulomb. Charge Q2 is what? Minus 5 microcoulomb, which is what? Minus 5 times 10 raised to power minus 6 coulomb. And we are given the distance R1, displacement I plus J minus K, everything in meter. The R2 is what? 2I plus 3J minus 2K in meter. We are asked to find the what? Determine the force acting between the charges. So the first of all, between the charges, we are using what? Is using force Fk Q1 Q2 into displacement R2 minus R1, everything keep into what? R2 minus what? R1. That's it. This is R1. So I apply this first of all. Let us find the what? Displacement what? R, which is what? R2 minus R what? 1. Displacement R. What is R2 from the question? R2 is 2I plus 3J minus 2K. And minus R1 is I plus J minus K. You have it in this form, 2I plus 3J minus 2K. Expand this, minus I minus J plus K. We have this. Add this one together, we have 1I from this plus 2J plus this plus 1K. This is what? Our displacement. And the next thing is what? Let us find the what? The magnitude. So the magnitude of what? Displacement, it will be what? Square root of coefficient of I, which is what? 1 square. Coefficient of j is 2 square. Coefficient of k is 1 square. By doing that, the magnitude of vector will be what? Square root of what? 1 plus 4 plus 1, 1. So you now end up with what? Square root of the magnitude will be what? Square root of what? Of 6. So the next thing is what? We can now substitute for each what? We have known the what? This displacement r this to be equal to this, and we have known the what? The magnitude, which is equal to this. So let's substitute what? Substitute for each value. By doing that, we have f should be k is 9 times 10 raised to the power 9. Q1 is what? 2 times 10 raised to the power minus 6. Q2 is 5 times 10 raised to the power minus 6. Everything over what? So at deduction, we need to what? To neglect the minus and the plus we have in front of what? In front of charge. So what is this R magnitude? Is what? Is root 6. Our R magnitude is what? Root 6. Everything into what? Raised to power 3. Raised to power 3. And multiply by what? Or let me put it into the bracket. Into bracket what? R2 minus R1, which is what? We have I plus 2j plus k. That's it. So if we press what? Calculator, vowel 2 times this is 10, times this, it will give us what? 90. Abi? 90, then this is minus 12, so by default, for this, if you press your calculator without mistake, the force supposed to give us what? F will be equal to what? 6.215 times 10 raised to power minus 3 into what? I into what? I plus 2j plus k. Everything in what? In Newton. This should be the what? The final answer for the first question. So let us solve the second question. We are given the two charges are located on the positive x-axis of coordinate system. The charge is what? This. Question number what? Number 2. Let's check it now. The solution to number 2 question. What is the first charge given? Q1 should be 2 times 10 raised to the power minus 9 coulomb. And the second charge given is what? Wait, a second charge given is 3 times 10 raised to the power 3 times 10 raised to the power minus 9 coulomb. Yes. And the third charge given, Q3 given, is what? 5 times 10 raised to the power minus 9. 5 times 10 raised to the power minus 9 coulomb. Good. Yes. You say what? Axis coordinates. Charge this is 2 centimeters from the origin. That is, this R1, R what? 1 is 2 centimeters. 2 centimeters from what? From origin. which is what? 0 point what? 02 in meter. What is R2? The R2 is 4 centimeter from origin. 4 centimeter from origin, which is 0.04 meter. What is R3? R3, they said, what is the magnitude of total force exerted by the wrist to charge on this? Located on the origin. So the R3 located from origin simply means what? From a 0 what? Meter. We are now asked to find the what? What is the magnitude of total force exerted by two charges on a charge of this? If you look at the questions here, they said located on a positive x-axis. If you could still remember from the knowledge of what Cartesian coordinates, where we have what x, y, x. This y is what is j, x is what is I. So if we have what z like this, okay. The z here we call it what k. So I'm told that what for the x-axis is supposed to be in what the positive x-axis coordinate of the system. So the distance here, this 2 meter here, for I it will be 2 meter high meter. This one will also be in what? In I meter is 0, nothing. So the next thing that we now to apply here is we will find what? For displacement. We are asked displacement for R to 1, it should be what? R vector R 3 to what? 1 over what? Magnitude of R3 minus this R. That will be that. You now have what? What is with the what? R3. Distance of R3 is what? Is 0 minus what? 0 point R1, 0.02I. Everything over what? Magnitude of what? 0 minus 0.02I magnitude. So this will give you what? Minus this. Then square this, then find the what? The square root. By doing that, we will end up square of this, the square root give you all this. We cancel each other. We are end up later with what? Minus what? Minus I. By factorize this. And the second one is what? We have known the what? The displacement unit. The next one now is what? The force. The force exerted by what? By 1 to the what? To 3 charge. To the first charge to the what? First charge is will be Q1 or Q3 and as what? Q1 over everything is what? Is R displacement R31 everything what? Square into display unit displacement of what? 31. So by going with this, we will end up to force 3 into 1 charge 9 times 10 raised to power what? 9 into the what? Q1 is Q3, sorry, is 5 multiplied by 10 raised to power what? This into what? What is Q1? Times 2 times 10 raised to power what? 9. Everything into what? If it's about this, it gives us 0.02 everything square. The R unit here is what? Times minus 1I. So by pressing the calculator, the force exerted by first charge to the third charge, it will give us what? Minus 2.25 times 10 raised to power minus 4 I Newton. That's the force. The next one is what? Let us find the force exerted by charge Q2 on what? On Q3. So to know the force exerted to what? To charge what? Q2 on 3, we have what? Our R3 2. This unit, it will be what? R2 minus R what? 3, everything over what? R2 minus vector of what? R3 what? Magnitude. So you have it in this form. The R32, which will be what? So you have, what is the distance to? 4. Be 0 minus 0.04 I over what? 0 minus 0.04. The same thing, we add up with what? By solving this, this is the magnitude, don't forget. Square this, find the square root, you see how about 0.4, 0.4 what minus what minus I. Abi, or let me solve it, we have 0.4 I over here, we have what? If you square it plus 16 and find the square root 0.4, 0.4. This will cancel each other, but here we have minus, we have what? Minus I. That's what they have. So by doing that, the next thing is what? To find the force. The force on the charge, it will now be what? F32 will be Q3 Q2 over what? R what? R32 square multiplied by what? R32 magnitude this. So by apply this now, we are 32 to give us what? 9 times 10 raised to power what? 9 multiplied by what? What is Q3? Q3 is what? 5 times 10 raised to power minus 9 multiplied by what? 3 times 10 raised to power minus 9, which is which is what? Q2 and what? Q2 and Q3, we have what? This. I mean, what will be the what? The distance is 0.04 everything what? Square multiplied by what? The R here, and R here you get here is what? Minus R. The R unit you get here is what? Is minus this R. So by pressing the what? The calculator, we are going to have the what? The force on set to the charge 3 by charge 2, which will be minus 8.4375 times 10 raised to power minus 5 I Newton. And we are asked to find the words from the question, the total force exerted on these two charges. So the total force will be the what? The resultant force. So the resultant force, resultant what? Force FR, it should be now be equal to what? Force 31 plus what? Force 32 vectors. By adding it together, what the resultant force now? The resultant force will be what? Force 312, the first one we have is what? Minus 2.25 times 10 raised to power minus 4 plus this minus 8.4375 times 10 raised to power minus what? 5. Don't forget that what? Here we have what? I. Here we also have what? I in Newton. By adding it together, we have the resultant force to be equal to the what? So that force should be minus 3.09 times 10 raised to power minus 4 I Newton. But what will be the magnitude of resultant what? Force. The magnitude is what? We will square it and find the square root. By square, this minus is what? We remove. We will end up with what? 3.09 times 10 raised to power what? Minus 4. The I will remove Newton. That will be the what? The final answer.